Okay, well, today we'll continue in our discussion of descriptive statistics. Let me just get this going here. Stats 10, week 2, Friday. Okay, so on Wednesday we talked about the mean and the standard deviation. Okay, so we have discussed the mean as a way to describe the center of the data set. And what did I say was the conceptual definition of the mean? I said the mean can be thought of as the balance point of our data. And the standard deviation is a numeric quantity to express what? What aspect of our data? The spread, okay? So it's a numeric quantity to express spread. And today we will learn two more. We'll learn the median as a way to describe the center and the IQR as a way to describe the spread. But before we get there, we have to discuss the mean and standard deviation a little bit further. And so one use of the standard deviation and the mean is to discuss z-scores, okay? Or in essence, we can identify observations that are considered unusual. Okay, and so we can say, maybe it would help to define what a usual or typical observation are observations that we see frequently, okay? Are observations with values that we see frequently. So an unusual would then be defined as something that we see infrequently, okay? And one way to express this is that, if our data is unimodal, okay? Unimodal and, well, in general, if it's unimodal, and then especially if it's also symmetric. So if your data has kind of this shape, what that means is that values near the center, near the mean, will be frequently observed. Whereas values far from the mean are infrequent. Okay. Now, when we talk about values being near and far from the mean, we're talking about distances. However, we don't have an exact quantity and say like, 7 feet from the mean, that's high or low. When we talk about these distances, we want to express them in standard deviations, okay? Okay, so being near or far. We want to express the distance in standard deviations. And so when we do that, that will be defined as the z-score. So I'll let you guys catch up on your writing, those of you who are writing. And so the z-score is defined as the distance an observation is from the mean expressed in standard deviations. Okay, so I'm going to just make up some numbers here. Okay, this is a made-up example. I have no idea if these numbers are even remotely true. Okay, made-up example. Okay, let's say the mean age of retirement is 61 years old. Okay, we'll just pretend. I don't know if that's true or not. Okay, and we will also say that the standard deviation of retirement ages is 4 years. Okay, and so what this means is that if someone retires at age 65, okay, this person is retiring 4 years above the mean age, okay? But 4 years is one standard deviation, so we would say this person's z-score is 1, okay? We might say +1, okay? Meaning 65 is 4 years above the mean, and one standard deviation is equal to 4 years. So he is, or he or she is 1 standard deviation above the mean. Is that okay? All right. So if someone retires at At 61, what is their z-score? Z is equal to 0. Z is equal to 0. This person is retiring at the mean, so z is equal to 0. And if someone retires at, let's say, 59, what is their z-score? Negative 1/2, right? Negative 0.5. Is that okay with everybody? And so, what we're kind of doing in our head is we're saying z is whatever value we have. We're taking our x, we're subtracting off our mean, mu, and we're dividing by the standard deviation sigma, okay? So it's, or if we're using sample values, x minus x bar over s, these are all saying the same thing. So we're saying x minus the mean divided by the standard deviation. As we're saying, we're finding the distance from the mean by doing x minus the mean, and then we're taking that distance and we're expressing it in standard deviations by taking that distance and dividing it by the size of a standard deviation. All right, and so with this, we get an idea of what is unusual or what is not unusual, and this is based on something called the empirical rule, okay? The empirical rule, okay, this applies to many distributions. Okay, and is very accurate for unimodal and symmetric distributions. Okay, and the empirical rule says this. It says that about 2/3 of the data, technically closer to 68%, is within one standard deviation of the mean. Okay, so for our retirement example, we said the mean is 61. Each standard deviation is 4 years. So approximately 68% of people retire between 57 and 65, according to the empirical rule. The empirical rule also says that about 95% of the data is within 2 standard deviations of the mean. So as far as our example goes, we would say about 95% of people retire between what? 53 and 69. Okay, is that good with everybody? We're going 2 standard deviations. Each standard deviation is 4. So if I go 2 standard deviations below the mean, that's 8 years below the mean of 61 and 8 years above the mean of 61. Right? So this is, just in case it wasn't clear, I'm doing 61 minus 4 times 2. And this over here is 61 plus 4 times 2. Okay, and then lastly, almost all, so it's 99.7% of data will be within 3 standard deviations of the mean. Okay, so okay, I think you guys get the picture here. Okay, so the conclusion is that we have some guidelines for determining what is unusual. So we can say if the z-score is over 2 or under 2, that might, under negative 2, that might mean it is unusual. Okay, so z's greater than 2 or z's less than negative 2 indicate the observation is unusual. Okay, because about 95% of data is within negative 2 and plus 2 for z-scores. Okay, so if the z-scores are beyond that, then that means only about 5% of data is outside of that range. So this is, so we could say, you know, if it applies to only about 5% of the population, we might say that's a little unusual. Okay, and on the other hand, or even further, if z is greater than 3 or z is less than negative 3, that indicates the observation is highly unusual. Okay, because if 99.7% of the data, if nearly everybody's within 3 standard deviations, to find someone who's more than 3 standard deviations away would be highly unusual. Okay? All right, so let's try a little exercise out here, and we'll make a clicker question out of it. Okay? And so we will say, you know, which is more unusual? Okay, we'll say, you see 2 dogs, right? Okay, so one will say, which is more unusual? A Great Dane, which is a dog that weighs 190 pounds. So this is a big dog, okay? Or a Chihuahua that weighs, we'll say, 9 pounds. Okay? Which is more unusual, the 190-pound Great Dane or the 9-pound Chihuahua? Now, at this point, we can't really make the comparison because we don't know which, you know, the average size of a Great Dane or the average size of a Chihuahua. Okay? So I already did the research for you, and I'm kind of ballparking some of these standard deviation numbers because I couldn't figure these out. I couldn't find, like, they report average sizes, but they don't report standard deviations, you know. They're not statisticians in that regard. So, so for Great Danes, the mean is equal to, is about, you know, these are ballpark numbers, is around 160, and the standard deviation is 20. And for Chihuahuas, the mean is around 5 with a standard deviation of around 1.2. Okay, so go ahead and work through those, and we will say answer A if you think the Great Dane is more unusual. B will be Chihuahua more unusual. And C will be neither is more unusual than the other. Okay, I have to get the clicker software running here, so give me a second. So go ahead and try that out. You can discuss with your neighbors as you work through this. We're gonna stats 10, start a new session. Okay, so I will. So if you turn on your clickers, it should say AA stats 10. I'm hoping. Okay. As your welcome message. Okay, and then some of you guys are already clicking away to submit your answers, and that's great. We'll leave this open. So we'll let that run. Okay. You know what? If you're on the video, I'm going to just pause for a second. Okay, so let's just quickly go through this and talk about which one is more unusual. So we'll look at the Great Dane, and we're going to calculate the Z-score for the Great Dane. Okay, our Great Dane is 190 pounds, which that's a big dog. Okay, and you don't want to see that thing charging at you. So 190 pounds is our observation. We're going to subtract off the mean. So this Great Dane is 30 pounds above the average. And each standard deviation is 20 pounds, so this is 1.5 standard deviations above the mean. So the Z-score for the Great Dane is 1.5. Okay, this is Z for the Great Dane. And for the Chihuahua, okay, our Chihuahua weighs 9 pounds. Okay, the average weight of a Chihuahua is around 5 pounds. And the standard deviation is 1.2. So this Chihuahua is 4 pounds above the average weight of a Chihuahua. And when we look at the standard deviation, we see that, oh, that's actually quite a big number. So 4 divided by 1.2 is 3.33. 3.33, and this is our Z for the Chihuahua. Okay, so as far as Chihuahua goes, this is like the monster of Chihuahuas, right? So, because 99.7% of Chihuahuas would be between, would have Z-scores between 3 and -3, and this one is beyond that. Okay, so this is the Godzilla of Chihuahuas. I always, dogs always amaze me, just because you can have 190-pound Great Danes and 5-pound Chihuahuas, and they can breed together and make something in between. That amazes me. Okay, but anyway, so there we have it. The Chihuahua is certainly more unusual. Okay. All right, so it looks like most of you guys got that. Okay. Okay, so there we have Z-scores. All right, let's keep going. And now we'll talk about the median and the IQR. And we said, I believe on Wednesday, I said the mean and standard deviation might be preferred for symmetric data, and the median and IQR is, maybe preferred for skewed data. But the truth is these values can be used for any set of data, okay? Okay, so the IQR, well, okay, let's talk about quartiles and all of this stuff here. Okay, so the median is a way to measure the center, okay? Measures the center, okay? And it tells us it is the halfway point of our data. So the mean is the balance point of our data. The median is the halfway point of our data. Meaning half of the data is less than or equal to the median, and half is greater than or equal to the median. Okay? We can also say the median is the 50th percentile. then it's useful to define what we have, what we will call the first quartile. The first quartile is Q1. This is the 25th percentile of our data. Okay, so that means 25% of values are less than or equal to Q1. And likewise, 75% of values are greater than or equal to Q1. The third quartile is Q3. This would then be what? The 75th percentile of our data. Meaning 75% of values are less than or equal to Q3. Okay? So if you are being measured on test scores or something like that, where higher is better, you would prefer to be in the third quartile. Okay? Meaning that you are scoring over 75% of other people rather than being in the first quartile, meaning only a quarter of people are scoring below you. Okay, so we can also define the median because it's the 50th percentile. This can also be Q2, the second quartile, but I would say very few people refer to the median as Q2. Okay, so if we define the first quartile and third quartile as this, then the IQR, which is our interquartile range, it's like they had to pick the worst name, right? Is going to be Q3 minus Q1, and that's our IQR. This is our IQR. Is the difference, the distance between the third and first quartile. Okay. Okay, so let's just give a quick example here. All right, so there's supposed to be 180 students in our class. It looks like there's a little bit fewer than that today. But let's say, so we have a classroom of 180 students, okay? And let's say we went around and we asked, how much is in your bank account? Now I don't know, I have no idea how much you guys have, okay? How much money in your bank? Okay, so I'm completely making up numbers. If all of these numbers are wildly off, then don't hold that against me, all right? Okay, so let's just say we went around and we find out that the median amount of money, I don't know, $621, okay? I don't know, is that reasonable? All right, so what this means is that out of 180 students, 90 students have less than 621 in their bank, have less than or equal to 621 in the bank, and 90 students have more than 621, greater than or equal to 621 in the bank. Okay, we could further survey and maybe we ask, you know, we find out Q1 is I don't know, 180, okay? And so this means 25% of students, I'm sorry, not 25 students, 25% of students. So in a classroom of 180, this is about 45 students, okay? So 45 students have less than or equal to 180 in the bank. Okay, whereas, you know, the remaining 135 students, okay, have more than 180 in the bank, okay? And Q3, okay, and generally, anytime you're dealing with money, it's going to be skewed. So Q3 might be something like 1750 or something like that, okay? And so that means 75% of students, so something around 135 students, have less than or equal to 1750, okay? And so in this case, our IQR is the difference between Q3 and Q1. And we would do 1750 minus 180. And we would have 1570. So the IQR is 1570. And that means, you know, the distance between the kind of the top quartile and bottom quartile is 1570. I have no idea if these numbers are reasonable or if they sound too high or too low or whatever, but we'll just pretend this is just some numbers here. Okay, so this is what the IQR is, and so this gives us an idea of kind of where the middle 50% of people are within this span of $1,570. Okay, so 50% of people are between 180 and 1750. So there's 90 people between these two numbers. Okay. Okay, and also 90 people outside of these values. Okay, so 45 students will have less than 180 in the bank, and 45 students will have more than 1750 in the bank. Okay. So half of people are between these two numbers, and half are outside of these range. Okay, but we also have an idea of things where half are below this number and half are above that number. All right, so let's just do some quick work in finding the median and the IQR if we had a set of data. Okay. Okay, so finding the median and IQR. Okay, step number one in either of this is the most important step. Is arrange the values from least to greatest. You might see a question on a quiz or a test where I ask you to find the median or IQR, and the values have not been arranged from least to greatest, and if you forget to do that, your answers will be wrong. For the sake of time, when I do examples in the class, I will generally, like in this example I'm going to do here, the scores will be arranged from least to greatest already. Okay, so we'll say we have 12 scores, test scores. Okay, and I'm just making up some numbers. We'll say we go 60, 70, 72, 77, 78, 80, 83, 85, 88, 90, 92, and 96. Okay, so we have 12 test scores. And so first we're going to find our median. Okay, so this is, because there's 12 values, this is going to be the spot where 6 are lower and 6 are higher. So I count through here and I go 1, 2, 3, 4, 5, 6, and I draw a line. And so now I've got a line that splits the lower 6 from the upper 6. So this is going to be my median. My median goes right here. And we see that it is between two numbers, okay? So whenever you have an even number of values, so if n is even, the median is the mean of the middle two values. So in this case, our median, 80 plus 83 over 2, 81.5. So our median is 81.5. Okay. And then we do the same thing for Q1 and Q3. Q1 and Q3 are the respective, quote, medians of each half list, okay? Okay, so basically I'm going to treat these lower 6 as a set of numbers, and I'm going to calculate the quote median there. So that will go somewhere like right here. This will be Q1, okay? And then you do the same thing for Q3, okay? So go ahead, find Q1 and Q3 and calculate the IQR, okay? And we'll make another quick clicker question out of this. Okay, so find the IQR. And let me give you some answer choices here as far as the IQR goes. Okay, got 11, 18. Oh, and one more. Okay, so go ahead and try that out. See if you can find Q1, Q3, and the IQR. Okay, give you guys a minute to work through that. I think I did this correctly. Okay, I'm gonna, again, I'll pause the video here if you're following on YouTube. Okay, so resuming on. Okay, so Q1, we said, you know, we've got 6 values that are lower, so Q1 is going to be the spot that divides this into 3 and 3. So our Q1 will be the mean of 72 and 77. So we do 72 plus 77, divide that by 2. I get 149 over 2, 74.5. That's our Q1. Q3, I've got 6 numbers up here. I want to find the, quote, median of those 6 numbers. So I'm going to split this in half, and I'm going to put Q3 right here. Okay, so Q3 will be 88, the mean of 88 and 90. We're going to divide by 2, and this will just give me 89. Okay, and therefore my IQR is Q3 minus Q1. So I have 89 minus 74.5. I have an IQR of 14.5. Okay, so let's take a look there. Looks like, by and large, the vast majority of you got that. So that's great. Okay, and that's if we have an even number of values here. Okay, so let me just kind of show you what would happen if we don't have an even number of values. Okay. Okay, so here I'm going to say, here we have 15 values now. Okay, so n is equal to 15. And so these numbers, I'm going to just write them out. Again, they're already arranged from least to greatest, so you don't have to worry about it right now, but in test or quiz conditions, they might not be arranged from least to greatest, so beware. 85, 88, 90, 92, 96, 99, and 100. Okay. So here I have 15 values already arranged from least to greatest. Again, very important step that you do not forget. Okay. And so here we have n is equal to 15, and so our median is going to be the spot that divides it in two. Okay. Median will have, if we do 15 over 2, we get 7.5. So we're going to have 7.5 lower and 7.5 higher. Now you can't have 7.5 numbers. So what we do is we take the 7 and we round down, 7.5, and we round down to 7. And so I'm going to go through and I'm going to count 1, 2, 3, 4, 5, 6, 7, and I'm going to draw a line right there. On the upper side, I will also count down 7. 1, 2, 3, 4, 5, 6, 7. Okay? Because I want 7 values lower and 7 values higher. So I will have 7 lower, 7 values higher. Okay? And so this number in the middle, this is going to be my median. So my median is 83. Okay? We do the same thing. Once we've done this, now I leave the median alone, okay, and looking at just the 7, so do not include the median. Well, so these instructions will vary from textbook to textbook. Our textbook says do not include the median in your next calculation. Some other textbooks say you do include the median. But we'll go with what our textbook says. So we'll say do not include the median in the next step. So we're going to take these 7 lower values and find the quote median of those to get our Q1. Okay, so find the quote median of the lower 7 to get Q1. So looking at this, we say, okay, well, we do 7 divided by 2 is 3.5. We round down to 3, so find spot where 3 are lower and 3 are higher. So I go 1, 2, 3. I isolate that. I'm again treating just as if we had these 7 values. I go 1, 2, 3. This is going to be my Q1. Same thing over here. 1, 2, 3. Come in 1, 2, 3 from the upper side. This is going to be Q3. So Q3 is 92. Q1 is 72. My IQR, 92 minus 72. I have an IQR of 20. Okay, we'll end there, and have a great weekend, you guys. Stay safe in the rain.